Okay, Assalamualaikum. For part A is friction properties. Choose friction and then take sum of force, value, mass, speed. Okay, first choose the box with mass 50 kilogram and then set the friction in the halfway. Then set the applied force to 50 Newton. And for the result, we get a friction force is 50 Newton and left. The direction is left. And applied force is 50 Newton. The direction is right. And sum of force is 0. Okay, for the second situation is when box not in motion. That means it's static friction. First, choose the box with mass 50 kilogram and then set the applied force to 150 Newton and we can observe the result. We get friction force is 94 Newton and left. For the applied force is 150 Newton and the direction is right. And for the sum of force is 56 Newton. Okay, the last one is when the box in motion. Okay, first choose the box with mass 100 kilogram and then set the applied force to 500 Newton. Okay, we get the friction force is 188 Newton and the direction is left. Okay, after that, set the friction surface to none and immediately increase to log. And we get the friction force is 375 Newton.
For part B, coefficient of static friction, first of all, we need to set the coefficient of friction as 0.25. And the mass of M2 is 10, and now we need to change of the mass of M1 until the M2 is not moving towards the M1. So now I'm setting it to 2.5 and I run the simulation. So now it is not moving. What if I increase a bit? And it's moving. So we know that the M2 is the block M2 is not moving when the mass of M1 is 2.5. So it is stated that when the mass of M2 decreases, the load of M1 is also decreases. And it is the same for 30 degree angle. When the M2 is decreases, the M1 is also decreases. Now on a dry concrete on a rubber. So for this, I need to set the coefficient friction to 1. And the mass of M2 is 10 and the mass of M1 is 10. So let me run. So it is not moving. So if I decrease it a bit, it's still not moving. It is quite difficult to move on a rubber concrete. So that is why the value of both M2 and M1 is same. So what if I change the angle to 30 degrees? So when I change the angle to 30 degree and set the M2 to 10 and run this simulation, it's not still running. So I decrease the mass of M2. I decrease it to 8 kilograms. And I run the simulation, it's not still running. And I decrease more it to 6 kilogram. And it's running. So I have to decrease the mass of M1 in order to not making it moving. So I set the M1 as 8 and it is not moving. So we can conclude that when the M2 weight of M2 decreases, the load of M1 increases as per to not making the M2 is too moving. Thank you.